Given a car that runs a 195 degree Fahrenheit thermostat, what is this temperature in Celsius and Kelvin? Note that the Kelvin is lowercase there because that is the convention when referring to a unit defined in the SI system, but Celsius is really the name of a person. Kelvin is also the name of a person, but when you're referring to an established unit, you don't capitalize even if it's named after a person. So by the same token, when you say a force measured in newtons, if you write that as a word, you would not capitalize N in that context. So the way I'd like to approach this is we do have a formula for all of this on the key concepts page, and if you want to use those, write those down and just plug in, that is fine. But I want to share kind of a conceptual way of looking at this. So this 195 degrees Fahrenheit really represents a certain number of Fahrenheit degrees above the freezing point of water, and the amount that really is going to be 195 minus 32, since 32 is the freezing point in Fahrenheit. And so again, this kind of in my mind represents the distance you are as a temperature. I don't know if distance is the right word there, but the distance you are in a number line, that is, from that freezing point. And then I'm going to convert what that is to what that distance would be in Celsius. And since Celsius is the bigger unit, I expect there to be less Celsius as a distance from freezing as there would be in Fahrenheit. So I'm going to multiply by 5/9. And the 5/9, you might recall, comes from the fact that going from freezing to boiling, it's 32 to 212 in Fahrenheit, which is 180, 0 to 100 in Celsius, which is 100, and 100 over 180 is, or reduces to 5/9. So this is like a conversion factor between two units, even though I'm maybe not quite using notation that reflects that, but that's at least one way to conceptualize it. And if Celsius had a freezing point that was defined differently from 0, I'd probably want to add, or maybe subtract if it was negative, that number to this. But since Celsius is defined with freezing at 0, I don't have to do anything else, because this really tells me how many Celsius am I away from freezing, which really is the temperature in degrees Celsius. So my calculator says that when you calculate this expression here, it is 90.555 repeating. So I think I'll just round that off to 90.6 and state that that is in degrees Celsius. And then I'm going to take what I have in my calculator, which is like the 90.555, etc., and add to that 273.15 to get a number. That's going to be my answer in Kelvin. And my calculator says for that 363.70555, etc. I'm going to round that off to 364. That seems appropriate. It's a little bit debatable, though, how the sig fig rules should apply to temperature scales like this, because something to notice is, like, maybe I've actually lost some information in the rounding going from here to here, because really if I left it at 363.7, I'd be rounding kind of at the same decimal place as I did here, if you see what I mean. So it's a little bit debatable whether I didn't lose information there, and that's kind of a subtlety that you can sometimes think about. I often say sig figs are kind of a good rule of thumb and a guide, but it doesn't really replace human critical thought about uncertainty, and we can see that our answers do match what the slide says here.